Hello everyone, Assalamu alaikum. Welcome back to Dr. Teeth. Now today we are going to learn about the dental amalgam. This is a very important topic whether you are in your graduation or you are preparing for any entrance examination. Many questions could be asked from this topic. So in this video we will be trying to understand this in a very simple way because on Dr. Teeth I like to simplify things as much as I can. So let us see how it goes. And if you found the video helpful, do let me know in the comment section below. And also, if you're new to this channel, please consider subscribing. So let's jump into the video. Now here, let us start by understanding two terms. One of them is alloy and one of them is dental amalgam. So what is an alloy and what is dental amalgam? Alloy is a mixture of two or more metals. Okay. And dental amalgam is a type of alloy. Why type of alloy? Because it is a specific alloy where we have mercury with silver and tin. So now we know that what is an alloy and what is a dental amalgam. Now in dental amalgam, we have mercury with silver tin. Now you must be wondering why are we using mercury in the dental amalgam? Because mercury is said to be toxic. Now that is a controversial topic because the mercury we use in dental amalgam is far too less than the mercury we are actually exposed to from the external environment. So the main reason why dental amalgam is not being used in many countries now is because there is problem in discarding the mercury. Like let us suppose you have mixed the dental amalgam and you might need to discard some of it after the treatment. So that discarded dental amalgam, it is very difficult to get rid of it from the environment. It's very difficult to extract the mercury from that dental amalgam from the environment. So that is why in many countries now we are not using dental amalgam. But anyhow, since it is controversial topic like whether we should use it or not, why are we using it at the first place? Why not any other component? So the thing with mercury is that it is liquid at room temperature and we will be able to get a workable mass. Okay. So whenever we are dealing with any restorative material, what we need? We need it to be workable, right? And it should be able to set, right? Because we want it to set. So when we mix mercury with the silver and tin, we get a workable mass. And also, why did I write able here? I should have written set. So, and also it is able to set, right? So that is why we are using mercury. Now, why silver tin? Why are we not using any other thing with mercury? So mercury does not readily react with any other metal. So that is why we are using these two, right? So the major component is silver, okay? And then we add little amount of tin, say 25-28%. And then copper needs to be added and zinc needs to be added. Now, why are we adding copper and why are we adding zinc? That we will see as we proceed with this video. So let's keep the information limited to this, like we have mercury with silver tin and we have copper and zinc. Okay, that is dental amalgam. Let's move on. Now let us talk about the classification of dental amalgam. Now, dental amalgam can be classified by various means. According to number of alloyed metals, we can have binary, ternary, quaternary. Means it can have two metals, binary. Okay, Y means two. And if we have three metals, we have ternary alloy. If we have four constituent, we say it is quaternary. Okay, so that is one way of classifying the amalgam. Then we have according to the shape of the particles. We have irregular, spherical, spheroidal. Okay. Then according to the copper content, you must have heard about it, like we have high copper alloy, low copper alloy. We'll see why do we need to add high copper, high percentage of copper. But according to that also we can classify the amalgam. So low copper alloy generally have 2 to 6% and high copper have 12 to 30%. Then according to the zinc content. So there are zinc containing alloys and there are zinc free alloys. Okay. So when it contains zinc, it will just have 0.01 to 1%, and in zinc-free alloy, they will have, almost negligible zinc, less than 0.01%, negligible, right? And then according to whether the alloy is unimixed or admixed. So unimixed means that the chemical composition of each particle within the alloy is similar. And admixed alloys are the physical blend of different shapes of alloy, like the lath cut and spherical particle. Now you must be wondering what is lath cut and what is spherical particle. We'll be seeing this in the upcoming slide, don't worry about that. But just let's remember that amalgam can be classified according to the number of the alloyed metals, according to the shape of particle. This irregular one is the lath cut, okay? And then copper content, high copper, low copper, zinc content, and whether the alloy is unimixed or admixed. Now we come to the shape of the particles. We have lath cut alloy powders, we have spherical or spheroidal, and we have admixed. Let's see them. Now let us suppose we have a homogeneous block of an alloy and we cut that alloy into irregular particles, okay? If we cut that alloy into irregular particle, that will be lath cut. So these particles can be graded according to the size as fine grain or coarse grain. The fine grains have gone now, and here we have the coarse grain, means they are bigger in size, okay? So that is the lath cut powder. So when we have a block of an alloy and we cut irregular shaped particles out of it, that will be lath cut. And in case we have a molten alloy, okay? So here we have a molten alloy and we spray it inside a column having a inert gas. So inside this we have inert gas. So what will happen throughout its journey while it's traveling inside, the droplets of the alloy, as you can see here, they will solidify as they fall down, okay? Because of gravity they will fall down, okay? And they will solidify and they will form two shapes. They will form spherical or spheroidal shape. So that is here spherical or spheroidal. And then we have the admix, which is the combination of different shapes. So that's about the shape of the particle. We have the lath cut, spherical or spheroidal, and we have admixed. Am I pronouncing this correctly? If I'm not pronouncing this correctly, I'm sorry for that. Now we come to a very, very important topic, that is role of each metal in the dental amalgam. Now I also found it very difficult to remember. It is confusing. So I have tried to simplify this so that you can retain this information lifelong, hopefully. So let me know in the comment section if this helped you. So in the first slide, we had seen that silver was the main constituent, right? And to be specific, we have 68% of silver. Now silver, it is the main constituent, okay? And it gives the strength. But it has a problem. And that problem is that if we just use silver with the mercury, it will expand. The restoration will expand. So how do we deal with that? So for that, we add tin, okay? So what tin does? It decreases the expansion. But why aren't we using tin as a major constituent? Why not just replace tin here and make tin react with the mercury so that we don't get the expansion? We can't do that. Why? Because tin decreases the strength. So this person, the silver, has strength and this person has decreased expansion. So we know that nobody is perfect in this world, right? The same thing applies here. They are not perfect. So what we need to do, we need to accept the imperfections we have and move on. Okay. Tin also causes corrosion. Let us see why does corrosion happen. So in the powder, we have silver tin as the main constituent. So when the silver tin remains unreacted, they form the gamma phase. And that phase is the strongest phase. It does not corrode. But the problem is that it cannot stay there, right? It needs some support to form the matrix. And that happens when they react with mercury. So when silver reacts with mercury, it forms the gamma 1 phase. And when tin reacts with the mercury, it forms the gamma 2 phase. So this gamma 2, it is the weakest phase. But if you read some textbook, you will find that there is one more phase, the mercury phase, that is the weakest. But if you don't have mercury as an option, we will say that gamma 2 is the weakest phase. Now we know that gamma 2, which is formed by the tin mercury, that is the weakest phase. And this gamma 1, this lies in between the gamma and the gamma 2 in terms of strength, okay? And gamma is having the maximum strength. So along with these three phases, we also have voids. We'll see in the next slide a clear picture of the structure of the set mass. But see, here we have the gamma 2 phase. It is the weakest phase. It will corrode, it will make the restoration weak, and we don't want it, right? And how is it forming? It is forming because of tin, okay? So here you can see, because of the tin, we are having corrosion, okay? So how do we deal with that? So you can imagine tin having a crush on copper, okay? So when there is copper, the tin, instead of reacting with the mercury, the tin will react with the copper because tin has a crush on copper, okay? So what does the copper do? It eliminates the gamma 2 phase and it forms the eta phase or the epsilon phase, also called as the copper tin phase. And for this to happen, we need around 12% copper. That is why high copper amalgam are recommended because it can react with the tin and it can decrease the gamma 2 phase, which was a problem, right? Okay. We know that we add zinc also, right? So why are we adding zinc? It's because it improves the handling and it acts as a deoxidizer. So we can say that it is a scavenger. It is a scavenger of the foreign substances such as oxides. So whenever we have available oxygen, so zinc will rapidly react with the available oxygen and it will form a slag of zinc oxide, and that can be easily removed, okay? Now the question arises, when we have zinc free alloys, what happens to the oxygen? What do we do with that? So in that case, when we have zinc free alloys, the oxidation is prevented by carrying out the procedure in the inert atmosphere. So when we have an inert atmosphere, obviously there is no oxygen, so we won't need zinc. But there is a problem with zinc. It causes delayed expansion. For example, let us suppose we have amalgam and that amalgam is contaminated with oral fluid saliva. So that restoration will undergo delayed expansion. We also add some other elements like indium, palladium, because indium reduces creep, increases the strength, and palladium reduces corrosion and it provides greater luster, shine, okay? So that was about the role of each metal in dental amalgam. Let us quickly summarize. Okay, so we have the silver, which is the main constituent, 68%. It gives the strength, but the problem with silver is that it expands. So to deal with that, we got tin, but the problem with tin was that it decreases the strength, okay, because of corrosion. Why? Because it is forming the gamma 2 phase. By reacting with the mercury, it forms the gamma 2 phase, okay. So to get rid of the gamma 2 phase, we add copper because tin has a crush on copper. So when he finds her in the vicinity, okay, close to her, he does not give a damn to the mercury. He reacts with the copper and there is a formation of eta epsilon phase, that is the copper tin phase. And for this to happen, we require around 12% copper, means the high copper amalgam is needed, okay. And then we also add zinc because it improves the handling and it acts as a deoxidizer. We can say that it is scavenger. But when we have zinc free alloys, we deal with that type of amalgam in the inert atmosphere. And the problem with zinc was that there is delayed expansion. So I hope you understood this. Let's move on. So I hope you found the video helpful. You can cover your entire syllabus of dental materials on our website by enrolling in our Prime tutorials. And you can also join channel membership. So till we meet next time, take very good care of yourself. Allah Hafiz.